Welcome, everybody. Now let's take a look at how to implement microservices. So we often say that APIs are the front doors of microservices, right? By that, we mean that API serve as the entry point for applications logic behind a set of programmatic interfaces, and typically a RESTful, web services API. Now, this API accepts endpoints, process calls from end clients and implements functionality such as traffic management, request filtering, for example, routing, caching, authentication, and authorization for that matter. So, microservices implementations, right? Let's take a look at that. AWS has integrated building blocks that support the development of microservices. So, there are two popular approaches within AWS, whether it's Lambda or Docker containers. And the project you're going to do will be in Docker containers. That's the challenge later on. So if you're using, let's say, Lambda just takes care of everything, right? It runs serverless, it runs execution to meet your actual demand curve with high availability. Now, this means that there is no admin infrastructure needed, right? Lambda supports several programming languages and then can be triggered from other AWS services that could be called directly from any web or mobile applications. So one of the biggest advantages of Lambda is that you can move quickly. You can focus on your business logic and, of course, worry about security, and that's important. So this drives the scalable platform for you. The common approach to reduce operational efforts for deployment is container-based deployment, and that's Docker, right? So container technologies like Docker, for example, it's really skyrocketed for the last few years because of its portability, productivity, and efficiency, and security. The learning curve with containers can be steep a little bit, right? So you have to think about security fixes for your Docker images and monitoring. So the ECS, right, for example, Amazon ECS and Amazon Elastic Kubernetes Service, EKS, right? Both of these services eliminate the need to install, operate, and scale your own cluster management infrastructure. They do it for you. With simple API calls, you can launch and start Docker-enabled applications, query the complete state of your entire cluster, and access many features like security groups, load balancing, and of course the block store, EBS, volumes, and AWS Identity and Access Management, IAM roles. So AWS Fargate, by the way, is a container management service, right? That allows you to run serverless containers so you don't have to worry about provisioning them yourselves, configuring clusters or VMs to run containers. It does it for you. With Fargate, you no longer have to worry about provisioning enough compute resources either, like EC2 instances. It does it for you. Now, Fargate can launch tens and thousands of containers that easily scale up for you, right? So the ECS, for example, supports container placement strategies and constraints to customize how Amazon ECS places and terminates tasks. So a task placement constraint is a rule that is considered during task placement. Now, you can associate attributes, for example, right? Essentially key value pairs to your container instances, and then use a constraint to then place the task based on these attributes. So let's take a look at an example. You can use constraints on certain microservices based on instance types, right? Or instance capabilities, such as GPU-powered instances. That's a good example. Similarly, Amazon EKS runs up-to-date open, for Kubernetes. And you can use all the existing plugins, tooling from the community, right? Applications running on Amazon EKS are fully compatible with applications running on any standard Kubernetes environment, whether running an on-premise data center that you have or on a public cloud. So Amazon EKS also integrates IAM, enabling you to provide native authentication on Kubernetes. And there's no need to manually set up the credentials for authentication for Kubernetes masters, right? Master pods. So the IAM integration simply allows you to directly authenticate with the master itself as provide fine granular access for the public endpoint for the Kubernetes master, right? And Docker images, by the way, used in ECS or EKS can be stored in, the registry, the Elastic Container Registry, ECR. Now, ECR eliminates, of course, the need to operate and scale in the entire infrastructure required to power your container registry. So continuous integration and continuous delivery, CI/CD pipelines, popular in DevOps, right, is a best practice. And like I said, it's a vital part of DevOps initiative that basically enables rapid changes and frequent deployments of your software code. But of course, we're not talking about DevOps and more pipelines. You can take a look at the other course or lectures on DevOps that I have, right? But let's focus on primarily just the focus on private links. That's another thing I want to talk about, right? So AWS Private Link is a highly scalable, available, scalable technology that allows you to privately connect your VPC, and then you can take your VPC hosted by other AWS accounts. So VPC endpoint services, for example, and supported AWS Marketplace partner services, you can use any one of those. So you don't require an internet gateway, for example, or a NAT device or a public IP address. AWS direct connections, right? Or even VPN connections to communicate with the service. The traffic between your VPC and the service does not, leave the Amazon network. So private links are a great way to increase the isolation of microservice, by the way, right? That the microservice architecture. So example would be it's possible to create hundreds of VPCs, each hosting and providing a single microservice. So enterprise organizations can now create services and offer them for sale to other AWS customers, right? So, and of course they can do it through a private connection. So they create a service that accepts TCP traffic, hosts behind a network load balancer, for example, and then make the service available either directly or AWS Marketplace. And of course, they'll be notified of new subscription requests, and then you can choose accept or reject each one. So the power of AWS Private Link has merits, and of course, in any number of scenarios, it's of course particularly important or advantageous to SaaS organizations, right? So through this private link, these SaaS providers can see creative opportunities to use this networking construct to enhance and expand and use these microservices. So the implementation of these microservices can be done through private links. And of course, you can put it up on Marketplace and people can buy it or subscribe to your particular service. So there are many ways you can implement microservices, in summary, in a nutshell, right? You can do it through Docker, Kubernetes, private links, and again, that depends on your own architecture. And of course, at the end of this course, you have this challenge project that you will be doing hands-on, of course, step by step. It's going to take you about 2 to 3 hours, and I'm going to walk you through, or of course, this is for your homework, by the way. That project will be at the end of this course. And of course, any questions, let me know. With this, let's move to the next lesson.